Hey guys, let's solve some absolute value equations. Looking at my first example, I have the absolute value of x minus 2 is equal to 5. The first step when solving these equations is to make sure that the absolute value part of the equation is isolated. In this case, it is. I don't have any numbers on the outside. I'm not adding or subtracting anything. So my first step is completed. So now that I have that, I need to set up two equations. The first equation I'm going to set up is x minus 2 equals positive 5. So notice I just dropped the absolute value bars. The second equation I'm going to set up is x minus 2 is equal to negative 5. Now the reason why I'm doing that is because we know that absolute value means distance from 0. So in order to get a distance of 5 from 0, if you think of a number line, okay, you could go 5 to the right, which would be a positive 5, or 5 to the left, which would be a negative 5. So that's where these two numbers come from. So now that I have those two numbers, I'm going to go ahead and solve. These are two pretty basic problems to solve. So on the left-hand side, I solve for x by adding 2 to both sides. So x is equal to 7. And then for my second equation, I'm again adding 2 to both sides. So x is equal to negative 3. So those are my two solutions to this equation. And just like with any equation, we can go back and check our work by plugging in our answers. So 7 minus 2 is 5. The absolute value of 5 is indeed 5. I can also substitute a negative 3. Negative 3 minus 2 is negative 5. And the absolute value of negative 5 is also 5. Okay, so that was pretty basic. Let's look at our second equation. So now you can see that the absolute value is not isolated right off the bat. Okay, we have a minus 5 next to it. So the first thing that we need to do is get this part of the expression by itself. And we do that by using inverse operations. So we would add 5 to both sides. Okay, that gives me the absolute value of 2x minus 7, and that's going to be equal to 9. So now that the absolute value is isolated, I can go ahead and set up my two equations. Okay, my first equation is 2x minus 7 is equal to positive 9. The second equation is 2x minus 7 equals negative 9. Okay, and then now I would solve just like I would any other equation. I'm going to add 7 to both sides. 2x equals 16. I divide by 2. So x equals negative 8 is one solution. To solve my second equation. Okay, I'm doing the same inverse operations. And I get negative 1. Okay, let's go ahead. Let's solve one more absolute value equation. Okay, with this equation, we can see that there's a couple of things. There's two different numbers that are keeping the absolute value from being isolated right at the beginning. So I can highlight this if I want to show that I need to get rid of or move over this plus 2 and the 2 on the outside. So my first step would be to subtract 2 from both sides. Okay, and now that I'm at this step, do not distribute the 2. We don't want to do that. Okay, we undo this multiplication 2 times this quantity. We undo multiplication with division. So I'm going to divide both sides by 2. Again, I'm not distributing. I'm dividing out the 2. So I have the absolute value of 3x minus 7 is equal to 1. Okay, and then now that the absolute value is isolated, I can go ahead and set up two equations. I'll do it over here so I have some space. So 3x minus 7 is equal to 1. And 3x minus 7 is equal to negative 1. So I can go ahead and solve. Okay, just like other equations, I can get fractions. That's okay. Now I'm dividing, so I get my second answer of x equals 2. And again, I can always go back and substitute these answers into my original equation to check my work.